Hey guys, well, welcome to a new chapter, chapter 6, in a new book, and getting into kind of the beginnings of algebra. So this is lesson 6-1, powers and exponents. I'm pretty sure this is review material for you, but don't worry, I'll still teach it to you fully. And today's date is 1/30/19. Okay, so we're going to be talking about powers and exponents. And it's kind of funny to say it that way because they actually kind of talk about the same thing. Okay, so I'm going to start with a power. We're going to call him a big 5 with a little 3. And let's see, let's start with 3. So 3 is what we call an exponent. Okay, and the job of an exponent is to tell, or it tells how many times a base number gets multiplied by itself. Multiplied. Now, probably in that definition, you might have heard a word that you're like, what exactly is that? We'll get to that guy in a minute. That's the red guy. So, when it says, actually, let's talk about him now. So, 5 is called the base, and that's going to be the number that is multiplied by itself repeatedly. And that repeatedly depends upon the exponent. So let's going back to our exponent and tells us what to multiply the base by. So what we're going to end up with in this problem is we have 5 times itself until I have a total of 3 5s. And then I just do the math. And let's see, I get 25 times 5 for a grand total of 125. Okay, now you might say, okay, great, but how does that deal with powers, Rosner? Well, let's deal with that notion, shall we? So let's go over here. And a power is simply a way to write a multiplication problem. Because if you noticed, when I'm raising anything to a power, I'm just multiplying that number by itself as many times as the exponent tells me to. So power is, that looks like a way in a manger. Oops, wrong spot. Put them back in. Let's go here. I need to give myself some space here. Okay, so let's try that again. A way to write a multiplication problem where the factors are the same. So the base is the number getting multiplied by itself. The exponent tells us how many times to multiply a number by itself. When I put the two together, that is called a power. Now, this 5 with an exponent of 3 is read a certain way. So let's talk about that. So we've got 5 with a 3. That's actually read as 5 cubed. Because I'm going to multiply. It's like doing 3-dimensional shape, has a length, a width, and a height. and we get exponents, or we get labels that are cubed. Okay. Another exponent that has a special name is when we have an exponent of 2. We don't say 5 to the second power. We say 5 squared. Because when we multiply length times width, we get the area of a rectangle, area of a square, and what we're really doing is looking for how many perfect squares are inside of our shape. So how do I read the rest of them when I have any kind of exponent you can imagine? So we're going to use n as the any exponent, and we're going to read this as 5 to the nth power. So that's where that n comes, or goes to, nth power. Now, you don't need to draw the circle, but just kind of emphasizing the n. Now, that's a form we read every other exponent. If it's 4, 5 to the 4th power. If it's 10, 5 to the 10th power, and so on and so forth. Okay? So a word we talked about before is the word factor. And a factor is a term that is being multiplied by another term. Okay, so let's kind of do an example so we understand this. So we have, let's say, 5 times 3. And what we would say is that 5 and 3 are factors. And the reason is they're part of a multiplication problem. Okay? Their answer is called a product. In this case, it would be 15. So we would say 5 and 3 are factors of 15. Okay? We also have perfect squares. These are awesome. And perfect squares, that results from multiplying a number by itself. And if you think about it, when you are looking at a square, its dimensions are the same. So if we multiply two numbers that are the same, it actually would be representing a shape that is a square with 4 equal sides. Okay? So an example of perfect squares, we would have, if we had 5 times 5 equals 25, we would say 25 is a perfect square. It's the result, it's the result of multiplying a number like 5 by itself, okay? So that's perfect squares. All right, I've almost run myself out of room, so I'm going to go to my next screen. And let's kind of go back to this guy, 5 cubed. And that's going to be equal to 5 times 5 times 5. And we earlier said we multiply that out, and that equals 125. Okay? So each one of these has a name, each one of these components. So let's go through each of them. So the 5 cubed is called exponential form. And what that means is our value is written using exponents. Okay? Now you may hear people refer to this as the product of a power. Okay? All right, next one. When I want to actually calculate what 5 cubed equals, I do what's called expanded form, and I write it out as its actual multiplication problem. So expanded form. So this is a power of a product. So notice before with 5 cubed it was the product of a power, and now 5 times 5 times 5 is called the power of a product. Weird, huh? And then last but not least is what's called standard form. What we expect from numbers is to see it not written as a exponent problem and not written as a multiplication problem, but what does it actually physically equal? That's your standard form. In other words, the value. Well, what is that value of 5 cubed? And speaking of that, that brings us to the next guy, a perfect cube. So if a perfect square is the product of a number times itself, this is going to be a product when multiplying a number by itself and by itself. Okay, so I'm multiplying 5 times itself, 5 times itself, 5. The answer, the 125, is the perfect cubed. So if I have 125 is considered a perfect cube. And it's the result of taking 5 times 5 times 5. Okay? Now, I'm going to insert here a list of values that you should actually know. You shouldn't have to recalculate out. You can always do that, but it takes too long. So these are going to be perfect squares. You should know them from 1 squared to 20 squared. And then also perfect cubes. You should be familiar with them, 1 cubed to 10 cubed. Voila. So this is what we put into our notebook. Or if we didn't get it glued in, you're going to put in now. Okay? All right, we've got a couple of problems that we want to practice on the next page. All of this should have fit on one page, these 2 screens, and we're going to go ahead and practice things that you're going to see on your homework. So directions for this first group are going to say write each as the product of the same factor then find the value. Okay, so what are these problems going to look like? What you're going to do is you're going to see a problem written in exponential notation or exponential form. Okay, so you're going to see a base and an exponent. So job 1 is we need to write it as the product of the same factor. So this is going to be 4 times 4 times 4 times 4. I stop when I have 4 4s. Now notice I'm writing multiplication with the dots instead of with the x's. And then it asks us to go ahead and find its value. So what I'm going to do is I know what 4 times 4 is. That's 16. And I know what 4 times 4 is. That's 16. And if I've memorized my 1 squared through 20 squared, which is on that page before, that answer is going to be 256. Excuse me. Now, you do need that green part as part of the process because they're asking you to write it as the product of the same factor. So this actually is an answer that you would say, hey, I got this one done. Okay, let's try another one. Ooh, look at this. We can have decimals. So we have 1 and 5/10 squared. So we're going to write it as the product of the same factor. That would be 1.5 times 1.5. Okay. Now we're going to go ahead and multiply. And so what you're going to do is you're going to think about this as being the same as 15 times 15, right? We're going to ignore the decimals temporarily when we multiply. And we are going to remember we're going to have 2 digits after the decimal point. So I'm just going to draw myself a little note, 2 digits, okay? So again, if I know what 15 squared is, which I should, it's on that other sheet, I would say that's going to be 225. But remember, we need to put 2 digits after the decimal point. So my answer would actually be 2 and 25/100. Okay? Now, guess what? We can do the same stuff even with a fraction. So I'm going to put number 3 here, and I'm going to take 1/2, and let's cube it. Ugh, that's terrible cube. Let's try that again. Okay? So job 1. Oh, and I forgot to do some circling over here. Sorry. This is also part of the answer. This is the answer. And then over here, we're going to write 1/2 cubed is 1/2 times 1/2 times 1/2. And then we're just going to go ahead and remember when I'm multiplying with fractions, I'm going to be multiplying the numerators and then multiplying the denominators. That's really all this problem is. So I get a bunch of 1s times themselves is 1, 2 times 2 is 4, 4 times 2 is 8. So 2 answers I'm looking for is the expanded answer and the standard form, or the final value. Okay, let's do a different type of problem that involves exponents. We have 6 squared minus 3 squared. Okay, so what I'm going to do is I've got 2 things going on. I've got exponents and I've got subtraction. So we have some rules, which we'll talk about, I believe, tomorrow, that the first thing we're going to have to do is the exponents. So we're going to go ahead and figure out what these values actually equal. And these 2 perfect squares you should know how to get. So we've got 6 squared is 6 times 6, or 36. We still have the minus. And then we have 3 squared. 3 times 3 is 9. Okay, now that I've done that, now I'm going to go ahead and do the operation. Okay, and when I take 36 and subtract 9 from it, I get 27. So that's the answer to that. Now I have one more set of directions, and then we'll be done for today. Write each product using an exponent. So now this is us taking expanded form and rewriting it in exponential form. If those words don't trip off your tongue, make some flashcards, make sure you get them. So this is super, super easy. So you'll see something like 8 times 8 times 8, and your job is, well, my base is 8, and how many times does it show up? 3. Bada boom, bada bing. That's it. Done. Super cinchy. Okay, let's try another one like that. And then we'll wrap it up for the evening. Well, yes, the evening. So I have 1/7 times 1/7 times 1/7 times 1/7. Ooh, I changed my multiplication symbols. Times 1/7. So I see 1/7 repeatedly. So I'm going to surround it by parentheses. And I'm going to add a little note here, very important. Must use parentheses if the base is a fraction, which it is in this case, or a decimal. Okay, so we're not done yet, right? Because we need to come up with our exponent. And 1/7 shows up 1, 2, 3, 4, 5 times. So this answer would be 1/7 to the 5th power. Okay? All right, have fun with this, guys. Bye.